Under the Bernoulli's principle, we want to discuss the topic, that is dynamic lift, Magnus effect. Dynamic lift and Magnus effect. Dynamic lift is the force that acts on the body by virtue of its motion through the fluid. Okay, what is a dynamic lift? Lift. But how in the motion it is lifted? That's why dynamic lift is the force that acts on the body by virtue of its motion through the fluid. Okay, this is one object I am lifting, but it is a solid I am lifting. But here object is lifted, but in the motion, lifted and in the motion, lift and motion. The dynamic lift is a force. How it is moves? One force. Dynamic lift is a force acts that on the body by virtue of its motion through the fluid. Okay, this is the meaning of dynamic lift. Now we want to prove that. Now let us take one ball in the fluid, means in the air. You take one ball is in the fluid, means air. The air is treated as a streamlined flow. When the ball is taken in the air or a fluid, the streamlines are arranged like figure 1. Figure A shows ball moving without spin. Streamlines are equally distributed above and below the ball. Means the ball is moves, your thrown ball, okay, in a fluid, in a air. So figure shows ball moving, it is not spins. Ball moving without spin, streamlines are equally distributed above and below the ball. The velocity above and below the ball is the same. Means the streamlines are there. So above the ball, below the ball. Above the ball, below the ball, velocity is same, resulting zero pressure difference. When the velocity is same, the pressure difference between above and below the ball, what happened? Zero. There is no upward or downward force acts on the ball. Okay? When the ball is thrown like this. But when it is thrown, the streamlines are arranged as shown in the figure. So above the ball, below the ball, the streamline's velocity is not changes, velocity is same. That's why it results to the zero difference in pressure. There is no difference in the pressure. That's why there is no upward force, there is no downward force acts on the ball when it is in a motion. Now figure 2. Here what happened? Ball rotates, means spins. So above the ball, below the ball, we take 2 points A and B. Above the ball, velocity becomes V plus VR, and below the ball, velocity becomes V minus VR. What is VR? VR means rotating velocity. When the ball is in the fluid or in the air, the ball drags. What happened? Drags some fluid around it. Drags some fluid around it. When it is drags the fluid around it, but the ball is moves in this direction. In this direction, the dragged velocity is VR. This VR is in this direction. So here V minus VR. Here velocity is same, above and below, but here what happened? Here this rotating, dragging velocity of the air is in opposite direction. but here in the same direction. That's why above the velocity becomes v plus vr and below becomes v minus vr. Why? The ball is in air, it starts to dragging some velocity around it, so that below the ball the velocity is decreased, above the ball velocity is increased. So the difference in the velocity is occurred above and below the ball. The difference is occurred in velocity, it resulting to the difference in the pressure. That's why the force is acts on the ball. But where the velocity is more, on the top of the ball velocity is more, at bottom the velocity is less. That's why at the bottom velocity is less, pressure is more, at the top velocity is more. So pressure is less, here pressure more and pressure less. That's why the force acts in upwards. Force acts upwards and moves and also spins. It is called by the dynamic lift. Now that I am explained here, figure shows ball moving with a spin. Ball moving with a spin. Why it spins? What happened? Occur due to drags the air. Means figure B shows ball moving with a spin. Streamlines are crowded. Streamlines are crowded above the ball than below. Above the than below. The velocity air above the ball is large, that is V plus VR, and below it is smaller, V minus VR. Above the ball velocity is longer, below that one velocity is smaller. As a result, there is a pressure difference between lower and upper faces. Pressure is less at the top of the ball and pressure is more below the ball. Means below the ball pressure is more, at the top pressure is less. Why? Here velocity is more, pressure is less, but here velocity is less, the pressure is more. There is a net upward force acts on the ball is occur. Why it is happen? It is occur due to drags the air by ball, so that ball rotated means spins with its own axis and moves upwards. Means nothing but dynamic lift is occur. Now this is dynamic lift and also called Magnus effect. That is very, very important. Difference in the velocities of air, results the pressure difference between lower and upper faces and brings the ball upwards with a spin is called Magnus effect. Means when the ball is in air, above and below streamlines are same, that figure A shows that, but when the ball is moves, it drags some air around it. How much air is dragged? The dragging velocity is VR. The dragging velocity like this, that's why top of the ball velocity becomes V plus VR and the bottom velocity becomes V minus VR. So velocity is more at the top, velocity is less at bottom. The velocity is more at the top of the ball, the pressure is less, but at the below the velocity is less, that is V minus VR, so pressure is more, so the difference in the pressure is there. So the ball not only spins and also moves upwards, means dynamic lift is occurred. But this is called by the Magnus effect. But how we can define that? Difference in the velocities of air, the difference in the velocities of air, the pressure difference between the lower and upper faces and brings the ball upwards with the spin is called Magnus effect. This is very, very, very important question in this chapter for 4 marks. Okay. The another application of Bernoulli's principle is aerofoil or lifting of aircraft wing. Aircraft wing means aeroplane is lifted. How the aeroplane is lifted? First you take, it must be take runway, then after it lifts and moves upwards. Take runway, lift and moves forward. Here also Bernoulli's principle is applied. Now, this is the wing of aircraft or aeroplane, that is called aerofoil. This is aerofoil or wing of aeroplane or aircraft. Its design is resembles to the wing of the bird, means the front side area is more, when it is moves in backward or behind, the area what happened? Decreases. Now, aerofoil is designed like a wings of bird. Aeroplane has two wings. That's why aerofoil is designed like a wings of bird. When aircraft is moves in air, streamlines are oriented as shown in the figure. Means when aircraft is in a motion, these are the wings. Here area is more, but here area is less. Here area is more, but here area is less. So the wind is blows with a high velocity on the above the wing, but below the aerofoil, the streamline's velocity is less. So above and below the aerofoil, streamlines are crowded. But this is the top of the wing. The top of the wing velocity of air more than below of it, means above the velocity of the air is more than below of it due to its shape. Why it is happened? Here area is more, backside area is decreases. That's why here due to the shape of the wing or shape of the aerofoil, the velocity is more at the top and velocity is less at the below of the wing. As a result, pressure is more above the pressure is more below the aircraft than above, with resulting in the dynamic lift. With resulting or not with which resulting? Which resulting dynamic lift means above the wing velocity is more, below the wing velocity is less. Above the wing velocity is more, below the velocity is less. So below the pressure is more and above the pressure is less. So which resulting the dynamic lift of the wings, and this balances the weight of the plane. Means when aeroplane is moves on the aerofoils, on the wings, its shape is like this. So on the top of the wing, velocity of the air is more, and below the air is velocity of air is less. So the pressure is more in the below than above. So difference in the pressure is there, which leads the which one or which is causes for the dynamic lift of the wings, and this balances weight of the plane. On both sides what happened? The dynamic lift is occurred. So aeroplane is moves and lift. So it is called dynamic lift. Okay, this is another application of Bernoulli's principle. One more small example is also there, applications of Bernoulli's theorem. A heavy wind, now let us take the houses which has the roofs, by the asbestos sheets, but not like a which one RCC building which has the roof, huts like that. When the wind is blows with heavy speed, means above the roof the velocity is more, but below the roof velocity is less. When the wind is blows with a high speed, then above the roof the velocity is more, below the velocity is less. So below the roof pressure is more, above the roof pressure is less. The difference in the pressure is causes the dynamic lift. In heavy winds, house roofs are blown off when the velocity of the wing is greater on the roof of the top than inside the house. Then the pressure on the roof of top becomes less than that inside the house. This pressure difference causes the dynamic lift. That's why the roofs are blown off. That's why when the wind is blows on the roofs, the air should be enter and exit. It is not happen on the top of the roof velocity is more, but inside the velocity is less, but inside the pressure is more, and the top velocity pressure is less. The difference in the pressure blows off the which one? The roofs. Next one. When a fan is rotating, papers are blown off from the tabletop. The velocity wind on the paper increases due to fan. Hence, the pressure decreases due to the pressure difference. Paper are blown off. Now, let us take. This is a book. If it is opened, wind is blows on here when the fan is rotates. When the wind is falls on that, here velocity is more. So, the pressure is less, but below of the paper, velocity is not there, here velocity is not there, pressure is more. That's why here the pressure is more, here the pressure is more, here the pressure is less. When the fan is rotates, that's why papers are blown off. When the papers are blown off in this side, when the pressure here is more than the below of the paper, immediately the papers blows off, which is on the table or like this also. When fan is rotating, papers are blown off from the table top. Why? The velocity wind on the paper increases due to fan. Hence, the pressure decreases. The pressure decreases on the top of the paper, but pressure is more at the bottom of the paper. The difference is what happened? Blown off the paper from the table. Not only that one, you take a calendar also. When the fan is rotated, the calendar is blows off like this. Why? When the wind is false, the pressure is velocity is more, pressure is less, but at bottom velocity is less, pressure is more. That's why the calendar which is hangs on the wall, when the fan is rotating,